Welcome to section 5.4. Here we're going to do two things. The first is the greatest common factor. And so it may be good for us to remind ourselves what these terms mean. So a factor of a number is a number that divides it. Okay, so a factor of 12 is, and we've been naming them, so a factor of 12 is 1, because 1 divides it, or 2, or 3, or 4, or 6, or 12, right? Those are all factors. So notice a factor is smaller than the target number. And so we use greatest common factors when we have two numbers and we want to reduce them, right? We want to picture them in a fraction. We need to reduce them. We need to find a number that goes into both of them evenly. And there's other applications as well, but the most common one we're used to is reducing a fraction. And so we're looking, remember what we're looking, so a factor is a number that let me actually word it like this. A factor of a number is never bigger than the number. And I'm stressing this, this might seem really lame, but I'm stressing it because we're going to do two things: greatest common factor and least common multiple. And so if I can get you to remember that a factor is smaller, then it will tell you what to do, because you use the same window to go through and do that. So there's two methods that they introduce and ask about in the homework to find the greatest common factor. Between two numbers. If you only have one number, then the greatest common factor is the number itself. I should say two or more numbers, right? I'll say that, but I won't go back and rewrite it. So one method is called the prime factorization method. And it's a really good method, and one that is actually better than the other because it can naturally extend up to the least to help you in the least common multiples. The prime factorization method has you do exactly what the title implies first. Prime factorize each number. Second step, look at each factorization and take let me say, only the factors that are common and the least amount in any factorization. Okay, so I want to make sure you understand that. And the third step is to multiply those together. To find the greatest common factor. So I'm going to make up some numbers here, and then I'll grab one from the homework. So I want us to find the greatest common factor between a couple of numbers. Let me choose these two. This is what I saw in the homework. I'll start there. 225 and 525. We want to find the GCF of those using the prime factorization method. So step number one is to prime factorize each. So we look at 225, and the way you prime factorize is you just factor it. When I look at 225, I know 5 goes in there, and it goes in 45 times. 5 is a prime number, so I'll circle that because that's an end of a tail. 45 is 9 times 5, and 9 is 3 times 3. So the prime factorization of 225 has a couple of 3's and a couple of 5's. I think they want you to write it in this exponent notation when you answer questions in the book, because there are some times that they'll ask you what's the prime factorization. 525. 525 has us look at a 5. It goes into there, and it goes in 105 times. 5 goes into 105 21 times, and 3 times 7 is 21. And so what do we have? I'll list them in numerical order: 1, 3, 1, 7, and a couple of 5's. So what the greatest common factor is looking for is a factor of both of the numbers. Remember, a factor has to be less than 225 and less than 525 because it goes into it. And so the way we build that is nice. Look at each factorization, right, up at the top here, and take only the factors that are common. Let me stop there. As you look at these two, what are the common factors? 3 is a common factor, and 5 is a common factor. Okay, and then take the least amount in any factorization. So my choices are 2 3's or 1 3. I'm going to choose just 1 3. And I'll put a 1 there for emphasis. 2 5's and 2 5's, the least amount of 5's is 2. And so 3 times 25, or 75, is the biggest number that goes into both of them. 75 will divide evenly into 225 and 525. And sometimes in a word problem setting, we really need to know that number. But if we were reducing the fraction, we wouldn't necessarily need to do it because we could hack at it by taking out 5's and things like that, and then get down to it. But this is a great way to find the the greatest common factor. So in the book, I'm seeing some number combinations like this. Let's try it one more time. Let's look at something like 252 and 396. Let's use this same method. So we're going to have to divide them. So when I look at 252, I definitely see a 2, and I get a 1, 2, 6 coming out of there. You can do this on a calculator, right? 252 divided by 2, 126. Divided by 2, 63. Divided by 3, 21. Divided by 3, 7. And you stop as soon as you get all primes. So what's the prime factorization? A couple of 2's, a couple of 3's, and a 7. How about 396? 3 definitely goes in there 132 times. 2 definitely goes in there 66 times. 2 definitely goes in there 33 times. 3 definitely goes in there 11 times. And we're done because 11 is prime. So what do we have? A couple of 2's, a couple of 3's, and an 11. So when you're looking for the greatest common factor, you can only select the ones that are common. And so there's a 2 that's common and a 3 that's common, not a 7 or 11. It's got to go into both of them. And so if it has a 7, it can't go into the 396. And it has an 11, it can't go into the other one. And so we're trying to stay smaller, so we're going to take the least amount of 2's and the least amount of 3's. Would they happen to tie each other on that? And so remember what this is. This is 4 times 9. So the greatest common factor, the number that divides into them both that's the biggest, is 36. And we're finished, right, with that type of thing. There's another way to find the greatest common factor, which they are asking us to learn as well. And that is a division by primes. So in the book, they want us to find, or in the homework, they want us to find the greatest common factor between 430 and 340. So one way to do that is through division by primes. And so what you do is you write the two numbers, and it's a very efficient way to do it. This way is great in terms of getting to that GCF, and it's actually something like you would have done if you were reducing a fraction. You'd pull out a 2, you'd pull out a 3, or whatever it happens to be, and go forward and do that. So when you're looking at 430 and 340, the first thing to do is recognize any prime number that goes in there. 2 definitely goes in there. 2 goes into 430 215 times, and 2 goes into 340 170 times, right? You can use your calculator for that. Then you're going to say, well, is there another prime number that goes in there? 5 does. 5 goes into 215 43 times, and 5 goes into 170 34 times. Now 43 is a prime number, but even if I didn't recognize that, there's no number that goes into 43 and 34, so you're done. The greatest common factor is the product of those two. The greatest common factor for this problem is 2 times 5, which is 10. Very nicely done in there. They'll give you ones with 3 numbers that are in there, so let me grab another one that they have where you're using this type of procedure. What if we were looking at something like 585, 1680, and 990, and wanting to know the GCF, right? What is the GCF of the 585, the 1680, and the 990? So I haven't done this one. I didn't see it in the actual online homework, but it's here in the written homework. But I want to have one that's big where we could practice with it. 5 definitely goes into each one of those. So 585 divided by 5 is 117. 1680 divided by 5 is 336. And 990 divided by 5 is 198. So you don't have to start with the smallest factors. Just start with something that you see. Now as you look at these, do you recognize what all 3 are divisible by? I think there's a number. All of them, if you look at the sum of their digits, add up to be a multiple of 3. So I think 3 goes into each one of these. So we're going to take 117 and divide it by 3 and come up with 39. 336 and divide by 3 and come up with 112. And 198 divided by 3 and come up with 66. So you can only divide by primes. If you start dividing by a composite, it throws some things off. So 39, 112, and 66 are all divisible by 3 again. These are getting into our realm of memorization. So we know this is 13. 112 divided by 3 is... 112 isn't divisible by 3. And 66. So I thought it was going to be. So is 39 is just 3 times 13. That's not working. And so we are done actually right here. There's nothing that divides those 3 numbers. And so what's the GCF of those numbers? It is just the 15. I was hesitant because I was looking over to make sure I copied the problem right, and I did. The GCF is just 15 out of all of those, and we can just discover it like that. So about half your assignment, maybe a little bit less, is finding the GCF. The other half is finding the least common multiple. More applications here. You found least common multiples before when you had to take something like 2/7 and add to that 5/21. You would say, hey, I need a number that I need a common denominator. And so you would build these guys up in order to have that common denominator. Here it's very nice. The least common multiple is 21, right? And I can get it by just building up that first fraction. But there's the example of when you did it. It would be a lot harder if the question was different. If the question started out as 2 over 117 and 5 over 210. Finding the number that both 117 and 210 go into is a little bit more difficult, but we can get at it. Let's find it actually. So if we want to know the least common multiple, if we want to know the common denominator of that, we would go through a process. And there's a process using the prime factorization that's very smooth. Now remember what a multiple is. A multiple is a number that's bigger than the number. There's an infinite number of multiples. So I would be looking for a number that's bigger than 117 and 210 that they both go into, or at least as big as them. And that's what I'm after. And so we're going to build and build big. So the first step is to prime factorize each number. So this question in the book will be this: find the prime factorization of 117 and 210. Okay? So the first thing is to take 117 and prime factorize it in 210. Do you recognize a factor of 117? 7 plus 1 is 8 plus 1 is 9. 3 is going to go into this number because 3 goes into 9. So 117 divided by 3 is 39. 39, I hope you recognize that 3 goes in there 13 times. 210, 3 goes in there 70 times. This is 7 times 10, which is 2 times 5. So, make that 7 a little bit better. So what's the prime factorization? A couple of 3's and a 13. What's the prime factorization here? A 2, a 3, a 5, and a 7. So after you prime factorize it, the second step is to build your LCD by taking every unique factor to the highest number of times. It appears in any one factorization. So, why are we taking all of them? Because we need a number that they both can go into. We don't need, before we were looking for a number that divided evenly into each. Now we're looking for a number that's bigger than, so we're taking everything. So what's everything? Let me look holistically. Everything is that there's a 2, there's a 3, there's a 5, there's a 7, and there's a 13. We need them all. Now, how many 2's were there? There was just 1, so that's the highest number. How many 3's? There was 1 3 in the 210 and 2 3's in the 117. We need the highest time in any one factorization. We need 2. To take all 3 would make it super big. We need 1 5, 1 7, and 1 13. And so what do we have out of this? We have 2 times 3 squared times 5 times 7 times 13. 8,190 is the first number that they both will go into. Again, we make sure it's the first one by taking the smaller, we don't pack on this additional 3. We look at them individually and say, okay, we need at least 2, at maximum 2, right, in there, and coming out with the 8190. So in the book, they said, in the homework, they said something like this: find the LCM of 96 and 30. Let's practice with this again. Step number 1, prime factorize. So 96, 3, and 32. 32, maybe you think 8 times 4. That'll work. You don't have to think prime numbers. 8 is 2 times 4. 4 is 2 times 2. And this 4 is 2 times 2. So we have 1, 2, 3, 4, 5. We have 5 4's. 5 2's and a 3. With 30, we have a 3 and a 10 and a 2 and a 5. So what do we have? We have a 2, a 3, and a 5. Now we're going to look at these and take every factor that we see. So I see a 2, I see a 3, and I see a 5. and then we're going to take to the highest power we see in any one factorization. So my choices are 5 2's or 1 2. We're going to take 5. If we don't take 5, then 96 has no chance to go into it. 96 has 5 2's that need to be present in any number that it goes into. And so that's why we're taking that. But to take 6 is overkill. 6 is too much. That doesn't give us the smallest one. And so what is this? If we take 2 to the 5th times 3 times 5, 2 to the 5th times 3 times 5 is 480. Is the first time that 96 and 30 will both coincide in multiple wise. So this is something that's in a lot of it, a lot of the homework, because it's needed a lot and it's a good exercise. How about this? The LCM of 60, 70, and 90. Well, you can do it of 3 numbers. It works out great. So here we have 6 times 10. This one is 7 times 10. And this one is 9 times 10. 6 is 2 times 3. 10 is 2 times 5. And so we're done with 60 with a couple of 2's, a 3, and a 5. 10 is 2 times 5. And we're done with 70 with a 2 times 5 times 7. 9 is 3 times 3. 10 is 2 times 5. And we're done with 90 with a 2, a couple of 3's, and a 5. So what's the LCM? Easy, we build it. It needs a 2, a 3, and a 5, or the first one won't work. It needs a 7, and that's it. So how many 2's do we need? Choices are 2 2's, 1 2, or 2 2's. So let me underline as I talk. My choices for 2's, actually I'll do better than underline. I'll highlight. My choices for 2 are 2 2's, 1 2, or 1 2. I need to choose 2 2's. My choices for 3's are, my choices for 3 are 1 3, no 3's, or 2 3's. I need to choose 2 3's. My choices for 5 are 1 5, 1 5, 1 5. 1 5 is sufficient, and 1 7 is sufficient. So if we look at 2 squared times 3 squared times 5 times 7, we'll have the least common multiple of 1,260. That's way better than just trying to range through all the multiples of 1 and seeing if it works for the others. Super fast. The next type of question is wanting to make sure that you can understand when to do to tie in the GCF and LCM. So they give us 2 numbers that are factorized. So consider 2 numbers. First number is 2 to the 32nd, 5 to the 17th, 7 to the 22nd. And the second number is 2 to the 35th, 5 to the 23rd, 7 to the 14th. And what they want is they want A. What is the GCF? So remember what GCF stands for. Greatest common factor. This is the one where you're picking the common ones and taking the smallest amount so that you're underneath. So the common factors are 2, and the smallest number is 32, 5, and the smallest number is 17, and 7, and the smallest number is 14. That's the GCF, and you're done. And I think it's a selection type of thing. B is what is the LCM. So remember here, there's nothing common. Well, it's least common multiple. Here you're taking everything, right? And the highest number of times. So you need a 2, and you need it 35 times. You need a 5, 23 times. And you need a 7, 22 times. So they're just going to have you build it when it's already pre-factorized. One thing that I'm remembering is when you do these LCM questions, it seems like in every one they're asking you to type in the factorization, the prime factorization of the numbers. So you're going to literally type those in for parts A, B, and C, and then they'll ask you for the LCM in the end. The last thing that is happening is word problems. And so let me give you an example of some word problems. And these happen in the last three problems that are on the exam. Maybe four. I think just three though. Okay. Actually, I think four now that I'm looking at it. So we have Jim has 40 pennies and 100 nickels. He wants to place them all in stacks so that each stack has the same number of coins, and each stack only contains one denomination of coin. What is the greatest number of coins each stack could have? So what this is an application question to what we've been doing. So we have 40 pennies and 100 nickels. They're different, and we don't want to mix those stacks. So I know we have 140 total coins, but we want to make sure that no stack has a mixture. And so the real question is how can they be split up? Well, this is a greatest common factor type of problem. And that's kind of led with this whole what's the greatest amount. It can't be a multiple of them because you can't have more in the stack of pennies. You can't have a bigger number of pennies than you actually have. So we're wondering, if we were to split them up, what could they all have? And you may already see the answer. But essentially, in order to solve this, all we have to do is find the GCF of 40 and 100. Now, if you already know it, you can type it in. Like, I think you could look at that and see it. But I'm going to model what they're asking us to do, and that is to use the prime factorization method. 100 is 10 times 10, a couple of 2's and a couple of 5's. Now remember what the greatest common factor is. The factors have to be common. Great. I need a 2 and a 5. They're both common. And the smallest amount, 2 and 1. And so what do we get out of this? 2 squared, which is 4, times 5, 20. They can be placed in stacks of 20. I would have 2 stacks of pennies and 5 stacks of nickels and be set. And you might have seen that from the beginning, but just an application of it. Another type of question is something like this. I thought this was a good question. Azad sold some books for 65, I'm sorry, not for, at $63 each, and used the money to purchase concert tickets at $135 each. So here's an important part. He had no money left over. After buying the tickets. And they're going to ask two questions. What is the least amount of money he could have earned. Selling the books. And they ask one more, what is the least amount of books sold? Well, least amount of books he could have sold. So what's the key word in here? The key word is least. You're looking for a number that both 63 and 135 go into. So the amount of money he generates from the books is 63 times the value. So 63 will go into this number. Evidently 135 went in there perfectly because it had no money left over. So you're looking for the least common multiple of 63 and 135. Why? Because 63 goes into the number because he generated that money by selling books at $63 a pop. And 135 goes into it because he had no money left over, just restating what I said before. So how do we do that? Easy. We prime factorize 3, 21, 3, 7, and we get 3 squared times 7. 135, 5, 27, 3, 9, 3, 3. And we get 3 cubed times 5. So what's the least common multiple? That's the one that's bigger than them all, and so needs everything. So how many 3's do we need? The biggest amount we see, 3 cubed. How many 5's? The biggest amount we see, 1. And how many 7's? 1. And so what do we get? We get 27, right? That's 3 cubed times 5 times 7. We get $945. $945 is the smallest amount he could have generated. There's other ways that 63 and 135 hook up, but the first time that they would coincide is at 945. What's the least number of books sold then? So the answer to part A is that the least number of books sold is, well, that he could have sold, well, the least amount he could have brought in is 945 divided by the price that he was selling them at. And we're going to recognize that the least amount of books he can sold and have this happen is 15. And so there's some application problems at the end that make this seem like it could have some real value coming through. And it does. It has some real good thinking value as well. So enjoy 5.4, but let me know if there's questions.